Calculation of where you're getting the volume of your vial using the mass of water and the density of water, that calculation actually is part 7, so we're not going to get to that calculation today. So here we go. I have already mentioned, though, yesterday when I was showing you how to work, once you have the mass of your water and the density of water, how do you get the volume of water? I said we're going to use the factor label method. This idea of the factor label method is kind of like the rounding, in that the rounding is strewn throughout the course. The rounding is not just neat, it's like the way science works. Factor label is strewn throughout the course. Factor label way of working science problems is not just neat, it's like what other people out there do too. So in order to use the factor label process, we need to have a bunch of what I call equivalency statements. Either equivalency statements or ratios. Density is a ratio, works great, equivalency statements. So here we have some equivalency statements within the metric system. Which ones do you need to memorize? Which prefixes? Micro, milli, centi, kilo. Those 4. On a test, I'm counting on you being able to maneuver with those 4 at least. Okay. I won't throw something else at you. But homework's another story. Okay. So we can make equivalency statements. Now, is there uncertainty in, I think this is maybe one we looked at before, you know, what did I tell you? 100 centimeters is equal to 1 meter. Is there any uncertainty in the 100 or the 1? No, it's an exact relationship. Good. Which of these do you need to commit to memory? The inch one. You have to memorize that. There isn't a whole lot in this class that you have to memorize. That's one of them. Okay. So these actually are what we call the metric English relationships, okay, for length, volume, and mass. How about this one? Do you have to memorize this one? Within the metric system, 1 milliliter is exactly equal to 1 centimeter cubed. Very good. So there's kind of 3 steps. They don't go in order necessarily, but 3 aspects to this factor label approach to working problems. Before we kind of talk about these 3 and do an example, let me show you kind of what's at the heart of the factor label method of working problems. This isn't I don't teach math. There is definitely math in chemistry. But let's say you were going to multiply some fractions. Let's go ahead and do 3 fractions. And let's say you had 3/5, 5 halves, and 6/4. Okay, I'm going to multiply those 3 terms together. We can kind of think as that being one big divisor where we have 3 terms in the numerator and 3 terms in the denominator. I think that, is it factor out? I use the word cancel. Is there anything you can see that we can cancel here? Well, we can definitely cancel the 5s. If a term is in the numerator and the denominator, it cancels out. Anything else? Yeah. Oh, let's see, the 6 and the 2. Yep. So I can take this, actually 6 is 3 times 2. Bless you. So I can take this 2 and this 2. That might be about it. That seem right? So if I was going to rewrite a new ratio, what would that be? Yep, I'm liking 9, because the only things that are left are these 2 things, 9/4. Yes, exactly. You know, when, okay, I got like ink all over my hand. I got something that's leaking in my office. One of the prerequisites is algebra, and we're not going to do a lot of like x is equal to y is equal to solve for. We're not going to do a lot of that necessarily, but this sort of thing in algebra is one of the things we are going to do. So, all right. So, I said no naked numbers. That's what this number, first one is. No naked numbers. Yeah, I use the word naked. People listen. So if you have a number and it's measured quantity, you should always have the units following the number. So I mentioned equivalency statements. In order to work the factor label method, a lot of times, in order to get down the road from point A, bless you, from point A to point B, isn't that weird? It's not working. From point A to point B, you're going to come up with an equivalency statement, okay, or a ratio. And then the last step, and again, these aren't necessarily in order, but kind of looking holistically at the factor label method approach to working problems, is you are going to set up your terms, kind of like I set up my 3 terms here. You're going to set them up so that they're going to be numbers, they're going to be units cancel. And how do units cancel? Well, like you told me, they cancel if you have units in the numerator and the denominator, they cancel each other out. That's it. That's the magic of the factor label method. So we're going to work this problem. Okay, so we're basically going to convert, let's see if my pen works now. It stopped working. We are going to convert from, it's just downright dead. We're going to convert from feet to inches. I'm going to stop this and see if it'll come back again. It just died. Died one other time. So, how many feet, it's actually on the next slide, how many inches are there in 1 feet? There are 12. So we would say 1 foot is equal to 12 inches. 1 foot is equal to 12 inches. That's the first step in trying to kind of come up with getting our way down the road from feet to inches. Now if I were to ask you how many inches are in 2 feet, you'd be like, okay, so 1 foot, 12 inches. 2 of those, 24 inches. Half a foot, 6 inches, so 24 plus 6 is 30. So you probably could think through that. Notice that actually I went ahead and put the decimal here. We talked about ambiguous kind of maybe zeros before an implied decimal. I put the decimal here. So fingers please, how many sig figs are there in the number 30 with a decimal? I'm liking 2. There are 2. And actually we're going to work this problem the long way, not just take it out. And we're going to see how we're allowed 2 sig figs. So here we go. You guys told me 1 foot is equal to 12 inches. How many people, raise your hand if you think that's an exact, by definition, relationship? I do too. No uncertainty there. How many people think that there's uncertainty in the number, the original number of the previous slide, 2.5 feet? How many people think there's uncertainty there? I do too. There is uncertainty there. So we're going to use an equivalency statement as a conversion factor. We're basically going to take a flat out equivalency statement and make a ratio out of it so we can kind of line it up and use it like this. Okay? So there are 2 possible ratios you can get from any flattened out equivalency statement, 2 ratios. And the way you get them is by dividing both sides by the same thing. So we could take the equivalency statement, 12 inches is equal to 1 foot. We could divide both sides by 1 foot. And what's 1 foot by 1 divided by 1 foot? That's just the number 1. Okay? So basically, what you have come up with is a unity ratio. That sounds fancy, doesn't it? What happens if you have a bunch of things lined up and you stick in, I'm going to multiply by 1. What does that do to the stuff you're multiplying? Doesn't change anything. So we can stick this ratio anywhere, it benefits us, and we're just multiplying by 1. The other one, instead of dividing by 12 feet, we can divide, instead of dividing by 1 foot, we can divide by 12 inches. And of course, in this case, 12 inches divided by 12 inches is 1. And so we have these 2 ratios. What's the relationship between these 2 ratios? We call this left one A and the right one B.
They're both equal to 1.
They're both equal to 1, that's right. And then what's another relationship? Yep, they're the flip or the inverse of each other, exactly. So every equivalency statement, you have a pair of options. You can go like this one on the top, okay? Or you can do this one on the top. And you're gonna pick the one that gets you down the road. So if we go back to working our 2.5 feet to inches, I wish my pen were working. I hope I can figure it out. What I usually do, if you want to in your notes, put 2.5 feet over 1. And the reason I put it over 1 is I want to make sure that I remember that units of feet and the number value of 2.5 are at the top of the numerator. So just like we did here, if we want units now, not numbers, but if we want units of feet to cancel, are we going to put it on the numerator or the denominator? We're going to put it in the denominator. So if you look back at the previous page, those two ratios, which one am I going to go with? The 1 foot over 12 inches or 12 inches over 1 foot? Yep, exactly. 12 inches over 1 foot. That's it. Now you might be saying, well, Mrs. Snipes, well, you make that sound so hard, so dramatic. Well, okay, you're right. But it will help, the factor label method of working problems. So now if you put can you see just like we did over here, now our feet cancel. Notice when I work problems in physical science, I just focus on the units. I don't care about the numbers. So feet cancel with feet, I'm left with units of inches. Now in my calculator, I just have to, the numbers that are left are 2.5 and 12. And so I multiply those together. When I multiply 2.5 by 12, my calculator, it's going to say 30. But we've been talking about this. Okay, you guys told me before we worked this problem, 2.5 has uncertainty in it. And how many sig figs in 2.5? 2, yeah. So my calculator spit back 30. Now if I write down 30 without a decimal, how many sig figs am I displaying? Just 1. 30 with no decimal is just 1 sig fig. So I have to go 30 with a decimal. Any questions about that?
It's not an implied decimal?
It is an implied decimal. It's an awesome implied decimal. But it doesn't, this versus this are two different numbers. There's an implied decimal here, but how many sig figs are there here?
2, right? No?
Nope. If I kind of try to do a dot. If there's no decimal here, there's just 1. If there's a decimal here, there's 2.
So if you had like 30.0, that'd be 3 sig figs, right?
Yep, you got it. Yep. Yeah. And remember, if we had like 3,000 and we wanted 2 sig figs, how would we do that?
3.0.
Yep. 3.0 times 10 to the third. Fun with numbers. Any questions about that? Okay, factor label, work problem. Factor label method of working problems. This is going to show you something silly. So for every equivalency statement, you got 2 ratios. What if we went with the other ratio? Okay, it's a unity, it's 1, and it's a relationship between the thing we start with which is feet, to the thing we want to get to. But what units would we have here?
Feet squared.
Yeah, feet squared per inch, which I'm sure that's helpful somewhere, but that's not where we're at yet. So the units don't cancel, so that doesn't make sense. So again, to me, and this approach to making sure your units cancel basically will give you confidence in working problems throughout chemistry, not just conversion problems like feet to inches, but working all science problems is going to help. All right, let's do another one. So tell me, because this one can't memorize, what's the relationship between inches and centimeters?
1 inch, 2.54.
Yes, 1 inch is exactly equal to 2.54 centimeters. Now, these last two we worked has been kind of a nice little one-step thingy, but they're not always like that, so let's check this out. when I work some of these problems, sometimes I'm going to kind of show you a flow of the problem. So we're going to go from centimeters to inches, just like the problem asked. And then over that arrow between centimeters and inches, I'm going to write the equivalency that you just told me. 1 inch is exactly equal to 2.54 centimeters. So that's just kind of a diagram of what we're trying to do. So what's our first term going to be?
5.52 centimeters.
Yep, 5.52 centimeters. I usually put it over 1. Very good. So what's our next step going to be? We're going to take that equivalency statement and make it into ratio.
1 inch over 2.54 centimeters.
1 inch over 2.54 centimeters. Does that make sense? And this is, remember, where there's all sorts of little themes throughout the semester. Show all of your work. That's one of them. Okay, so how many sig figs in 5.52? 3. Yep. How many, is there any uncertainty brought by the 1 here, 1 inch? Any uncertainty brought by the 2.54? No. So that's how we got to limit. Units of centimeters cancel because of how we set it up. And we have 2.17. And the units that are remaining are inches. That's it. 2.17, yeah. Any questions about that? Okay. You wish all of the problems were that straightforward, right? One of the reasons I didn't feel too bad in only sending you one part home for the long weekend is it'll make you think, I think, I hope. Okay, let's do another one. A while back on that slide where I kind of gave you some equivalency statements between the English and the metric system, one of them was with regard to mass. I think that's what we're going to use. Was it grams to pounds maybe?
Yes.
Grams to pounds. Notice if I have grams, so many grams, or 1 pound is exactly, or is approximately equal to so many grams, right?
Mm-hmm.
Okay. If I have that equivalency statement, that's not going to get me entirely down the road. Because instead of pounds on the English system, I've got ounces. How many ounces are in a pound?
16.
16. And I try to, I would say, on a test, I don't know if I make you guys know that, but I'm trying to be careful. We're going to take it, we're going to assume we know it. So we're going to use the whole pounds to grams thing, but we have to go from ounces to pounds. And you guys told me 16. 1 pound is equal to 16 ounces. That's going to be our first step. So we're actually going to have the starting term and then actually 2 steps after that. Is that an exact relationship? 1 pound is equal to 16 ounces? Yes, that's by definition. So then to get from pounds to grams, we're going to do this 453.6 grams is equal to 1 pound. Is that an exact relationship? No, that's approximate. So how many sig figs are in 453.6? 4. Yep. And no uncertainty brought by the 1 in 1 pound. So let's do it. What's our first term going to be?
2.75 ounces.
Yep, the thing we want to convert, 2.75 ounces. And again, if my pen were working, I would draw a line under that 2.75 ounces, and under that I would put a 1. So if we want ounces to cancel, how can we use this up here to our benefit? 16 ounces is equal to 1 pound.
It'd be like 1 pound over 16 ounces.
Yep, so it would be like 1 pound over 16 ounces, exactly. If you kind of keep up with it as we go, notice I went ahead and just scratched off that units of ounces cancel. All right, so we're down to units of pounds. How can we use the second equivalency statement to our benefit?
3.6 grams over 1 pound.
Yep, 453.6 grams over 1 pound. Now those pounds cancel. Yay! And again, I don't pay any attention to the numbers. They're just kind of along for the ride until the very end. Any questions about that? So we have units of grams. Cool. So is there, you guys already, did I already ask this? How many, is there any uncertainty in the 2.75 ounces? Yep, there's definitely uncertainty. How many sig figs? 3. 3 sig figs. No uncertainty brought here. You told me 5 sig, excuse me, you told me 4 sig figs here. So how many sig figs we allow in our answer? 3. That's it. That's totally it. I don't have my calculator here. You can check me. But do you see, we were just talking about this. Do you see where 78 is a different number than 78.0? Yeah, 78 is just 2 sig figs. 78.0 is 3 sig figs. Cool. All right, let's do another one. Let's see, we must have an English metric thing going on here. Milliliters, of course, is metric, cups is English. Back a few slides ago with that kind of yellow or orangish looking thing with the whole metric English relationships, I think I must have had liters to quarts?
Gallons to liters.
Gallons to liters, oh goodness. Oh my gosh. So if we're gonna use gallons to liters, then we have to get cups to gallons and then get our liters to milliliters. We could do that. Can't remember how to do this. Yep, check out. Look how wide these spaces are. So assuming that the only thing you have access to is the gallons to liters. So here we go. We'd have to go to get to liters from milliliters. Okay. And then from liters, we could go to gallons. And it looks like I'm not making, I can never remember. Does anybody know how many cups are in a gallon? It's like 64. Yeah, I think, I know, it's like a trivia question. So you wouldn't have to do that on a test, but I'm guessing 64. Okay. So yeah, that's assuming that's the only equivalency you were given. So a few slides ago, we say that exactly 1 liter is approximately equal to, exactly 1 gallon is approximately equal to 3.785 liters. So there's uncertainty there in that 3.785. So what's the relationship between, what's the equivalency statement between milliliters and liters?
1,000 milliliters to 1 liter.
It is. 1,000 milliliters is equal to 1 liter. Yep. Or you could say that 1 milliliter is equal to 0.001 liters. And it can get you down the road also. But I prefer this one. So 1 milliliter is equal to 0.001. Either way will be fine. All right. And I already told you the 64. Oh, no. Oh, man. Is that right? So what's 64 then? Let's be ounces. 64 ounces. Because there's 16, wait, no. There's 8 ounces in a cup. So if you take 16 times 8, you don't get 64.
128. Yeah, I thought 128.
Okay. 128 ounces in a gallon. Oh, don't quote me on that whole thing. Okay. So are we okay with this though? Is this an exact relationship? Yeah, it's like a by definition. So what's our first term going to be? I know, it's like you.
275.
Yep, 275 milliliters over 1. Perfect. So we need milliliters to cancel, so how can we use this first equivalency statement to our advantage?
1 liter over 1,000 milliliters.
1 liter over 1,000 milliliters. Very good. So milliliters have canceled. We're left with liters. How can we use this second equivalency statement to our advantage?
Liters to gallons or gallons to liters. So 1 gallon over 3.785 liters.
1 gallon over 3.785 liters. Perfect. So again, my pen's not working, and I'm not going to write on the. I don't know where. So milliliters cancel, liters cancel with gallons, so how can we use this last one to our advantage?
16 cups over 1 gallon.
Yep, 16 cups over 1 gallon. So unit-wise, gallons are just now canceled, so we left with units of cups, that's it. Now, everybody's a little bit different when you plug this into your calculator. What I like to do is like begin parentheses, and I would take my 275 times 16, end parentheses, get my divide by key, begin a new set of parentheses for the denominator, take 1,000 times 3.785, end parentheses. That's what I would do. Some people like to take the numerator, hit enter, and then divide, and then they divide by, begin parentheses, I guess, and hit the denominator. So, how are we going to round this? How many sig figs? See, fingers, yeah. I heard it, 3. 3 is correct. Any questions about that? 3. This doesn't drive our rounding because it's exact. The 1 and the 1 here for gallons and liters is exact. No uncertainty here with 1,000. 4 sig figs here. We have 3 sig figs there. So what did you get? Did you get the answer? Did you get this? Here's what I got. 1.16 cups. Cool. All right. Here's one for you, and I'm going to do this 2 different ways. I'm going to do kind of a quicker way, a direct way, and then an indirect way. The direct way assumes that somebody has given you the direct relationship between miles and kilometers. So we want to convert 120 miles to kilometers. How many sig figs in 120 as written here? 3. Yeah, so don't lose that information. It's easy to do to take they're like little story problems, aren't they? To take the information from kind of this little story problem and say 2 sig figs, but there's really 3 there. All right, so going the direct, and do you have to memorize this relationship? No. Exactly 1 mile is approximately equal to 1.609 kilometers. Cool. So what's my first term going to be?
120 miles.
Yep, 120 miles, 3 sig figs, over 1 usually. Okay, so I have units of miles. I want them to cancel, so how can I use this equivalency statement to my advantage? Yep, we're going to put the 1.609 kilometers over the 1 mile. So units of miles cancel. So fingers, how many sig figs do I need to round it to? 3. Very good. So did you get this number? Okay, so the number around the 3 sig figs is 193. And of course the only units that we have are kilometers. So, can't believe I totally butchered the cups in a gallon. But do you guys, does anybody know how many feet there are in a mile?
5,280.
Yep, 5,280 feet in a mile. And that is by definition.
There's 3 feet in a meter, right?
There's approximately 3 feet in a meter. It's not exact.
3 feet in a yard.
Yeah, and a yard and a meter are very similar. So yeah, there's exactly 3 feet in a yard. Yeah. So this would be the indirect way, assuming that the only thing you know is the one that you're supposed to commit to memory. You guys told me 1 inch is exactly equal to 2.54 centimeters. So as long as you know the relationship between miles and feet, 5,280, then you're down the road to go ahead and get it from miles to kilometers. 5,280 feet is exactly equal to 1 mile. So that's an exact relationship. How many feet what's the relationship between feet and inches? Yeah, 12. 12 inches exactly equal to 1 foot. Now, in this case, I can't remember how I'm going to do this. My slides, my bills are, but in this case now we need to get from centimeters to kilometers. You know, centimeters to kilometers, right? what I would suggest is going through the base unit instead of trying to figure out how many powers of 10 there are between those two. So what's the relationship between centimeters and meters? 100, yep. And so 1 meter is exactly equal to 100 centimeters, perfect. And then what is the relationship between meters and kilometers? 1,000, yep. Now make sure, and you're in good company if you mix up which is which. So for centimeters, 100 centimeters is equal to 1 meter, and for kilometers, 1,000 meters is equal to 1 kilometer. So, whew. All right. So here we go. Our first term is going to be that 120 with 3 sig figs, 120 miles over 1. What's the next term going to be? I'll use that equivalency statement up here. Cool.
280 feet over 1 mile.
Yep. 5,280 feet over 1 mile, since we want miles to cancel. So how do we get feet to cancel with the next equivalency statement?
1 foot or
Yep.
12 inches over.
We put 12 inches over 1 foot. Very good. All right. Now, everything's canceled except for inches. How can we use this centimeters and inches to make inches cancel?
2.54 centimeters over 1 inch.
You got it. 2.54 centimeters over 1 inch. Perfect. Now, inches canceled. We have units of centimeters. So how can I use this down here to get to meters from centimeters?
1 meter over 100 centimeters.
Yep, 1 meter over 100 centimeters. Perfect. Notice I'm having to kind of wrap it around on my slides. So now I have meters. How can I use this last one to go ahead and get to kilometers?
1 kilometer over.
You got it. 1 kilometer over 1,000 meters. Whew! Holy kalodi. So fingers ready. How many sig figs? I'm seeing a lot of 3s. That is right. 3 sig figs. So hopefully we get the same numeric value. We get the same value all the way around. Any questions?
It's possible it could be off by 1, right? Since 1.609 kilometers is approximate to 1 mile.
Yeah, it is possible that, yeah, the uncertainty would lie in the other way that we worked it, not this way. Yep, you're right. Yep. All right. Aside from this, okay, this talks about a balloon flying 14 meters per second. If you're driving down the road at 60 miles per hour, how far are you going to be 1 hour down the road?
60 miles.
60 miles. Okay. How long will it take you to get 120 miles? 2 hours. That's exactly kind of what we're going to do here. Notice that this kind of reminds me of the density that we used as a conversion factor. How fast is it flying? M/S. Meters per second. How fast is that balloon flying? 14 meters per 1 second. So we're after time for it to get a distance of 5 kilometers. I call it unpacking. So the 14 M/S means this. 14 meters, approximately 14 meters in exactly 1 second. Exactly 1 second down the road in, 1 second in time, gets you approximately 14 meters down the road. It's a property of the balloon at that particular time. Sometimes it goes slower, sometimes it goes faster. We could say 1 second is equal to 14 meters. This is similar. I hold the properties like, I pour the equivalency statements for down the road. What's the term that's not 14? What number is not 14 in that problem?
Seconds.
It's sort of. Are we after? How long will it take in minutes? Sort of. I was after the kilometers. The kilometers is the number, yeah. So we have to get from kilometers to meters. Oh, see, this is almost the last slide. It's like, dang it, I'm running out of time. So sorry, I yabbered too much. So we have to get from kilometers to meters, so we can use the 14 meters per second. And then once we get to meters, then we can use the loon's speed. Did you see I put two things up there? You guys told me the relationship of kilometers and meters is 1,000. 1,000 meters is exactly 1 kilometer. For this particular loon, it's going at 14 meters per second. 14 meters is 1 second down the road. And it's just like you were saying, what's the relation between seconds and minutes? 60, yeah. So you would tell me that 1 minute is exactly equal to 60 seconds. Kind of feel like I did this one fast. Well, if we go, just bear with me. If our first term is how far we want to go. If we make our first term 5.00 kilometers over 1, how can we use this relationship between kilometers and meters to get to meters? What do you think?
1,000 meters over 1 kilometer.
Yep, 1,000 meters over 1 kilometer. Kilometers cancel, we have meters. Now, how can we use the loon's speed to get from meters to seconds?
1 second over 14 meters.
1 second over 14 meters, perfect. And we could stop there if it wanted time in seconds, but we wanted time in minutes. So how can we use that last equivalency statement to get from seconds to minutes?
1 minute over 60 seconds.
Yep, 1 minute over 60 seconds. Now, unit-wise, the only units we have that have not canceled are minutes, which is perfect. So fingers, how many sig figs? I see some 3s. I'm going for 2. Why would I say 2?
14 meters.
Yep, it was kind of hiding here. There's uncertainty right there. So 2 sig figs, that's it. So you can double check, but giving it 2 sig figs, I got 6.0 minutes. So I mentioned your homework. So this part 3 homework will be due when we meet again on Wednesday. So you will have some kind of like this. I mentioned your homework isn't all straightforward. So some of it kind of, but it's good to get you thinking about the factor label method. Are there any questions? Let me know if you have, I know people are probably ready to go, but if you have questions on how to see the solutions, let me know, because my solutions are posted. Okay? If you have any questions during the weekend, I will be checking my email, because I don't have a life.